Algebra I 9.2a. This unit is about compound sentences, and we're going to talk about graphing conjunctions and intersections. We can graph a conjunction of two inequalities in one variable. So remember, an inequality has a less than, greater than, less than or equal to, greater than or equal to signs. And a math sentence like x is greater than 5 and x is less than or equal to 12 is called a conjunction. We can tell because that word and in the middle. A conjunction of two statements is made by connecting them with the word and. And a conjunction is true when both statements are true. A conjunction of two statements is like the intersection of two sets. Remember our intersection symbol? It was that big upside down U. Okay? So that's like a conjunction. The solution set is the intersection of elements of each individual set, and we can write them in set builder notation. When we graph inequalities, we draw them on a number line. If a number is included, we use a filled-in dot or a box bracket, like this or this, that faces the direction of the solution. So if we're given the inequality x is greater than or equal to 1, a negative 1, that means the negative 1 is included because it's or equal to. So we put a filled-in dot on the negative 1, and it's greater than, so we head towards the greater numbers, and we draw our line and our arrow going that way, see? If we're going to use the box bracket, we would put the box bracket facing the direction of the solutions, going that way, see? X is greater than or equal to a negative 1. Now, I prefer the bracket, because in Algebra 2, you're going to use that bracket. We need to write the solution in interval notation, and it would look like this. And you would use this line going on forever and ever and ever because it just says x is greater than a negative 1, so it could be 9 million, couldn't it? So it goes on forever, so we use the infinity symbol. It's the sideways 8, and we'd put a parenthesis there. And see how the bracket is right in the interval notation? So if you're using it to graph, you just put it down there when you write it in as the solution in interval notation. It's much easier. When we use the dot, we can write it in set builder notation. We could write this in set builder notation too if we wanted to. When we use an empty dot or circle or a parenthesis, notice that there's an I here, so there's just one. It faces the direction of the solution if the number is not included. So in the first one, it said x was greater than or equal to, so it included the negative 1. Now it just says it's greater than negative 1, so it doesn't include the negative 1. So we put an open circle and draw our arrow going in the direction that it's greater than that, see? For interval notation, we put a parenthesis facing the direction of the solution. And when we write it as a solution, we can say that in these set braces that the set of all x such that x is greater than negative 1. In interval notation, we just put the parenthesis, the negative 1, a comma, the infinity symbol, and then another parenthesis to close it off. Now, we always use a parenthesis next to an infinity sign. Whether we're going forever into negative infinity, you would do it like this. And if it was going forever into positive infinity, it would be like this. And you always put a parenthesis next to it. It never gets a bracket, okay? Now, look at this interval notation. If it's greater than or equal to, or even less than or equal to, because it's or equal to, it includes it, so it's going to have that bracket. And that says the 2 is included. If it doesn't include it, if it's just greater or less than, then we put the parentheses. It's not included, see? It says to graph the conjunction x is greater than 5 and x is less than or equal to 12. So if it's greater than 5, then 5 is not included. So we put a circle to show it's not included, and it's less than or equal to 12, so the 12 is included. We put a dot on the 12, and we draw our line in the middle to show that that's the solution. In interval notation, we would put a parenthesis to show it's not included, and a bracket to show it is. And in set builder notation, this is what our answer would look like. Right here, the set of all x such that x is greater than 5 and x is less than or equal to 12. And then for interval notation, which I think is much easier, we just put the parentheses, 5, the comma, 12, and the bracket, and we're done. See? Graph the conjunction x is greater than or equal to a negative 2 and x is less than 1. So it includes the negative 2, so we put a filled in dot, and it's greater than 1, so it doesn't, it's less than 1, so it doesn't include the 1. So we put an open circle, see? If that had the bar underneath it, then we could fill this in, but it doesn't. So that's our solution. And in interval notation, because the negative 2 is included, we put the bracket, and because the 1 is not included, we put the parentheses, and then that's our solution. So in set builder notation, we've got the set of all x such that x is greater than or equal to negative 2 and x is less than 1. And for the interval notation, look how easy this is. It's negative 2 with a bracket, see? And then a comma, and then the 1, and then the parentheses. Now look at this one. It says graph x is greater than or equal to negative 2, and x is less than or equal to 4. So they've got the or equal to on both of them. So it includes the negative 2. It includes the 4. And then we draw our line in between them. And we can use a bracket to show it includes the negative 2 and it includes the 4 and draw our line between them. And set builder notation, we would just write this with the set braces on the outside with an x here with our bar to show that the set of all x such that x is greater than or equal to negative 2 and, see, just like it's written here, x is less than or equal to 4. And for our interval notation, we just take this bracket, put it for our answer, and the negative 2 that it's above, comma, 4, and the bracket, see? That's why I like using the brackets and the parentheses, because then when you go to write the answer in interval notation, you're just copying right off the graph, see? Look at this one. It says, graph this. Now, how do you read this? Look at that. Well, actually, you start in the middle of the two inequality signs. So if you see more than one inequality sign, you start reading in the middle. So this is read as x is greater than negative 3. So you go x, and then you go to this side to the left, and then you go back to this side to the right, see? X is greater than negative 3, and x is less than 6, see? We went boom, boom, like that. So technically, we could have said negative 3 is less than x, and x is less than 6, see? We could have put the x 2 times with an and in the middle. So there is no or equal to, so we're going to have some open circles here, aren't we? Because it's just less than or greater than, right? So because it's greater than a negative 3, it does not include the 3, so we put the open circle. And it's less than 6, it doesn't include the 6, we put the open circle, and we draw our line in between to show the solution numbers. And if we use interval notation, we would just put a parentheses to show it's not included, and a parentheses to show it's not included, and draw our line. And our answer would be the set of all x such that negative 3, well, we'd read it x is greater than negative 3 and x is less than 6, see? So we'd start reading it in the middle. Now, an element is considered the intersection of two sets if it's in both sets, okay? So just remember that from our video about intersections, and if you missed it, there's going to be a link, okay? So I want you to check this out. We had x is greater than 5 and x is less than or equal to 12. Well, that's a compound math sentence because it has two or more inequalities. A compound English sentence for English grammar has two or more independent clauses. So here's an independent clause and there's an independent clause. I ran and I won. So we technically could have made two sentences out of this, couldn't we have? I could have just said I ran, period. And then I could have said I won, period. But I can put them together and make a compound sentence. It's like a conjunction. I ran and I won. See? I'm putting it together. Okay, so our next video is going to be 9.2b. We're going to solve and graph conjunctions and intersections. If you want to see the link for the union of sets or the sets and elements of a set or the roster and set builder notation, which is what I did here, the set builder notation, and if you want to see about intersections and empty sets, just go to this description and there'll be links that you can just click on and go to those, okay? So if you missed any of them. Watching my videos is like making a layer cake. If you miss a layer, it's not going to work. It's like following a recipe when you're cooking. If it says you've got to bake the cake before you frost it, and you say, I don't need to bake it, you can't frost a cake that's not been baked, right? So watching each video really helps, because then you understand what I was talking about before, all right? So I'll see you in the next video, and we'll solve some of these guys, all right? Bye.